Hello, welcome to this video on infinite limits. We're going to talk about what happens when a limit does not exist and what happens when a limit does exist and they go to infinity. And in video 2, we're going to talk about what happens when we go, as our x values go to infinity, and look at the limits there. Okay, so here we are. All right, so let's review. The graph of the function f of x equals x minus 1 over x minus 1 times x minus 2 squared times x minus 4 to the power of 3 has a hole at 1. Now, why is there a hole at 1? Well, when we cancel a factor top and bottom, this produces a hole or a removable discontinuity. Now, we have vertical asymptotes here for factors that did not cancel in the denominator, and you need to pay attention to the powers. So notice here we have an asymptote at 2, x equals 2, okay, and the power on it is 2, so I'm going to have essentially double asymptotes there, okay, so that's what we call an even vertical asymptote. And kind of some examples of this are here and here. Now, both of the function endpoints can go up towards the asymptote, or they can go down, right? That's an even asymptote. And then we also have odd vertical asymptotes when our power is odd, right? And that makes sense. Even, odd, odd. Okay, so here we have vertical asymptote at x equals 4, and because the power is odd, it's an odd vertical asymptote. Now, visually what happens? Well, you have endpoints, right, of your function that go up and down at the same time, okay, or it can be flipped. So visually, here are kind of examples of what they look like. So when we're talking infinite limits, or where a limit does not exist at a vertical asymptote, okay, we want to describe these limits as infinite limits, okay, and it depends on if they are even, and we have to look at the one-sided limits here. Okay, so let's go ahead and look at these, and we're going to use our knowledge of even and odd vertical asymptotes as well as the holes, and we'll see example 5 where we have a hole. Okay, so here we have example 1, the limit as x approaches 2 from the right, and if we calculate this, okay, we're going to get on top, we're going to get 5, and on the denominator we're going to get 0. This is undefined. Okay, so what we want to do is go ahead and do some sign analysis. So I'm going to plug in 2, right, from into the top, and 5, that obviously is positive. And when I plug in 2 here, sorry, let me move this, do my sign analysis over here. When I plug in 2 from the right, this means you're looking at a number bigger than 2. A bigger number than 2. Okay, so 2, a slightly bigger number than 2, take away 2, right? That's going to give you a positive value. So this is a positive. Okay, so what we get here is positive infinity. The limit approaches positive infinity. Okay, so now let's look at what if we have a number smaller than 2. Okay, so if I plug in 2 to my numerator, again, we get 5, right? So sign analysis, that's still a positive. And then if I plug in 2 from the left, this is a smaller number. Okay, so a slightly smaller number than 2, take away 2, that's going to give us a negative value in our denominator, which produces a negative value. So this limit is approaching negative infinity. Okay, and if we make sense of this, right, if we were calculating the limit as x approaches 2 of x plus 3 over x minus 2, this limit does not exist. Does not exist. Okay, and this should make sense, right? This is an odd asymptote. Now, how do I know it's an odd asymptote? Well, look at the power of the asymptote in the denominator. Okay, the power is 1. That's odd. Okay, so there you have it. Now, looking at example 3, I wonder what type of asymptote this is. Look at that power in the denominator. So we'll do the same type of sign analysis. I'm going to plug in 1 into my numerator. 1 take away 2 would be -1. And in our denominator, if I plug in 1 minus 1, we get 0. So again, we'll do some sign analysis. I plug in 1 into the top. We got -1. So that would be a negative value in our numerator. And in the denominator, a number just slightly, remember, 1 from the right, this is a bigger value, bigger, okay? That's going to be a positive value. So positive value squared, that gives me a positive. So negative divided by positive is a negative. So this limit is approaching negative infinity. Now looking at example 4, we're coming from the left, okay? And this is a smaller number than 1. So still in my numerator, right, I'm going to have a negative value. It's going to approach -1. And when I plug in a smaller value than 1 in my denominator, this value is also going to be negative, but it's negative squared, giving me a positive. Okay, so a negative divided by a positive is still a negative, and this is negative infinity. So both of these limits from the left and from the right, they approach negative infinity. So if we were to write this, right, the limit as x approaches 1 of x minus 2 over x minus 1 squared, this is equal to negative infinity. All right, and then example 5 down here, we have x squared minus 4 over x minus 2. So when I plug in 2, we get 0 over 0. Okay, that's indeterminate, and what we're going to do is we're going to factor this. So the limit as x approaches 2. I know it's annoying to rewrite this, but just do it. You have to do it. X minus 2 times x plus 2 over x minus 2. Okay, so our x minus 2 terms cancel, and what we get, right, is a whole. This is a whole at x equals 2. So this is equal to the limit as x approaches 2 of x plus 2. And when we plug this in, we obviously get 4. Okay, so there you have it. This is limits at infinity, okay? And we talked about even vertical asymptotes, odd vertical asymptotes, and talking about how we discuss the limits here at these infinite areas.